The relationship between AI and neuroscience, it's been pretty complicated. For a long time, AI researchers looked to the brain as the ultimate blueprint. Then they kind of went their own way, chasing raw computing power. But what if we missed the point all along? A fascinating new theory suggests the brain's biggest secret isn't how it learns, but how it teaches itself. And that secret could be the key to building AI that we can actually trust.
So in the early days, it was all about copying the brain. And it worked. DeepMind's famous Atari-playing AI was a huge win for that approach. But then came what's known as the bitter lesson. It turned out that just throwing massive amounts of data and sheer computational force at a problem worked, well, better. It was a brute force victory that left all that delicate brain mimicry in the dust. But now, this new sweet lesson suggests we might have been looking at the brain all wrong.
Okay, so here's the bottom line, the big idea right up front. The bitter lesson is simple. More data, more power, that's all you need. It says all those messy details about how the brain is wired are just a distraction. The sweet lesson completely flips that script. It says the real genius of the brain isn't just its ability to learn. It's this built-in architecture of, well, internal teachers. These are ancient, hardwired systems that are constantly guiding and steering the learning process. That might just be the secret to creating AI that doesn't just learn, but learns what actually matters.
Now, this idea comes to us from physicist Steve Burns, and he suggests we should stop thinking of the brain as one single thing. Instead, picture it as a partnership between two totally different systems, one that's a student and one that's a teacher. Let's break this down. You've got the learning subsystem, which is mainly your neocortex. Think of this as the flexible student. At birth, it's pretty much a blank slate, ready to soak up everything about the world. And then you have the steering subsystem, your ancient hypothalamus and brainstem. This is the wise, hardwired teacher. It doesn't really learn. It's been coded by millions of years of evolution with a very clear curriculum. Its job is to guide the student.
So how does this teacher actually, teach? It's not by rewarding some huge, distant goal like survive. I mean, that feedback would just be way too slow to be useful, right? Instead, evolution came up with a much cleverer system, a whole scaffold of intermediate rewards, little nudges, little dopamine hits for doing things that are helpful right now and boost our chances of long-term success. And these rewards are incredibly specific to whatever species you are. For us humans, yeah, food and warmth feel good. But so does play. That's practice for the future. And paying attention to faces, that's absolutely critical for learning social rules. But get this. A beaver's brain gets a little reward for picking up a stick. A squirrel's brain gets one for noticing acorns. Each internal teacher has a curriculum that is perfectly tailored to its students' needs. Okay, that makes a lot of sense for basic physical instincts. But what about abstract ideas? How does this ancient, hardwired teacher guide its modern, flexible student on concepts that it could never have evolved to understand? This is where the theory gets really cool. So let's just pose the question directly. Think about a complex feeling like, say, professional shame. You make a mistake at work, you feel that awful pit in your stomach. That's a powerful signal from your steering system, your inner teacher. But how on earth can your ancient brain, which only understands things like hunger and fear, possibly comprehend what a colleague or professional respect even is? This brings us to a classic puzzle in science called the symbol grounding problem. How do you connect an abstract symbol, like the word shame, to a real, physical, innate feeling? How does the teacher talk to the student when they're essentially speaking two completely different languages? Well, Burns's proposed solution is a special set of neural circuits he calls thought assessors. And you can think of these as the crucial translators, the interpreters that build a bridge between the ancient teacher and the modern student. Let's make this concrete with a simple example. Laughter. A baby is hardwired to laugh when tickled. That's an ancient response to a signal of mild danger plus safety. So one of these thought assessor circuits sees this happen over and over, and its job is just to learn to predict when that laugh is coming. But over time, that same circuit starts noticing more abstract situations that have a similar pattern, like the surprise punchline of a joke. The thought assessor connects the dots. And just like that, it allows your ancient brain to trigger a laugh for a totally modern abstract concept. It grounds a new idea in an old instinct. Okay, so why does any of this really matter? Well, this framework doesn't just change how we think about the brain. It has massive implications for everything from building safer AI to understanding our own mental health on a much deeper level.
For AI alignment, this is huge. Instead of trying to bolt on safety rules after the fact, we could design AI with its own internal steering system to guide its values from the very beginning. In psychiatry, you could start to see conditions like addiction or OCD not just as chemical problems, but as a faulty internal teacher stuck in a bad reward loop. And it gives us a whole new way to think about how kids develop, and even how we form our own identities.
To give you a real-world example, the AI pioneer Geoffrey Hinton once floated this idea that the key to AI safety might be something like a maternal instinct. You know, how a less powerful system, a baby, can control a more powerful one, its mother. It was a cool thought experiment, but Burns's framework of an internal teacher, well, that could actually turn it into a concrete, testable research program. Which brings us all the way back to the sweet lesson. We used to think the brain was just this incredible learning machine that we should try to copy, but this new perspective suggests something way more profound. True intelligence isn't just about the raw ability to learn, it's about having the right internal architecture to guide that learning. So the biggest question we need to ask, both for ourselves and for the AIs we're building, might not be how do we learn, but instead, who's doing the teaching?